Hello everyone. On behalf of my co-authors, today I'm pleased to present our research entitled Design and Construction Strategies Enabling Deconstruction Potential, a typology-based analytical study of the Greek Polykatoikia. This research explores how the conjunction potential can emerge implicitly within conventional building typologies, even when the buildings were never intentionally designed according to design for the construction principles. Our case study focuses on the Greek Polykatoikia, which is the dominant residential building typology throughout Greece. The construction sector is one of the world's largest contributors to ecological degradation. Globally, it consumes more than one-third of primary energy and is responsible for nearly 37% of energy related carbon dioxide emissions. Within the European Union, around 35% of construction and demolition waste is still sent directly to a landfill without material recovery. Another important issue is imported carbon, which can account for as much as 70 to 89% of a building's total life cycle emissions. To address these challenges, uh, design for deconstruction or DFD has been proposed as an upstream strategy. Instead of thinking about demolition at the end of the building's life, DFD considers material recovery from the very beginning of the design process. However, in practice, explicit DFD implementation remains extremely limited. Most construction projects are still driven primarily by capital cost, rapid construction, and constructability. This naturally raises an important question. What happens when DFD is never intentionally applied? That question becomes the starting point of our research. After reviewing the existing literature, we identify an important research gap. Most previous studies have focused on intentional design for deconstruction. They usually propose design guidelines, develop digital assessment tools, or evaluate post-demolition material recovery. However, very little attention has been given to a different question. Can conventional buildings also possess deconstruction potential, even though they were never designed for DFD? The Greek building stock is dominated by cast in situ reinforced concrete buildings that were designed mainly to satisfy seismic requirements, construction efficiency, and economy constraints. These buildings are usually regarded as having limited circular potential. However, we argue that their design and construction decision may still contain latent characteristics that influence future deconstruction. This research therefore shifts the focus from intentional DFD to implicit deconstruction potential embedded within conventional construction practice. Based on this research gap, our study has one main objective. We aim to identify how conventional design and construction strategies influence the construction potential. To achieve this objective, we develop a bottom-up analytical framework. Instead of beginning with DFD principles, the framework starts from directly observable technical evidence. These observations are then interpreted as the technical decision. Next, individual diseases are grouped into broader design and construction strategies. Finally, these strategies are interpreted to reveal the building's deconstruction potential. In other words, the framework moves progressively from what we can observe to what the observation actually means for future material recovery. The framework was applied to the Greek Polykatoikia, which is the most common residential building typology in Greece. Rather than analyzing only one building, we use the Polykatoikia as the representative building typology. The first step of the framework focused on identifying technical evidence. At this step, we recorded observable physical characteristics such as the structural system, material configurations, facade assembly, and construction methods. Importantly, these observations were collected without making any interpretation. They simply provide the factual basis for the following analytical steps. After identifying the technical evidence, the next step was to interpret what these observations actually represent. Instead of analyzing each technical detail separately, we grouped related technical decision into broader design and construction strategies. Using this process, we identify four recurring strategies. The first is dimensional alignment and geometric regularity, which reflects the regular structural grid and standard facade layout. The second is volumetric consolidation and infrastructure grouping. Thus, presenting the concentration of surface system within said vertical course. The third is monolithic continuity and interfacial fusion. This resulting from cast in situ, reinforced concrete and wet bonded construction. And finally, we identify structural envelope separation, where the structural frame remains physically independent from the non-structural infill ones. Together, these strategies deprive the overall organizing logics of the building rather than isolated construction details. The final step was to interpret how these strategies influence the construction potential. Our results reveal an interesting contrast. The strategy of monolithic continuity and interfacial fusion consistently acts as the main constraint. Continuous concrete casting and permanently bonded interface make future material separation and component recovery much more difficult. However, the remaining three strategies appears almost the opposite effect. Such as the structural and envelope separation improves the independence of non-structural elements. And dimensional alignment increases the flexibility because the repetitive structural layouts are easier to modify. Meanwhile, infrastructure grouping keeps building services concentrated in a predictable location and making future intervention easier. Overall, our findings suggest that conventional reinforced concrete building should not be viewed as entirely incompatible with circular construction. Instead, they contain both enabling and constraining characteristics depend on the specific design and construction strategy. To conclude, this study demonstrates that the construction potential should not be understood only as the outcome of intentional applying design for the construction. Instead, it can also emerge as a latent property and embedded within conventional building typologies. Using the work Polykatoikia as an analytical case, we showed that some conventional design strategies naturally support future adaptability, while others create barriers to material recovery. More importantly, we developed a qualitative analytical framework that makes these hidden characteristics visible. Although this framework wasn't developed using the Greek Polykatoikia, it's intended to be transferable to other building typologies. In future research, we plan to apply the framework to additional building types and integrate quantitative indicators together with empirical deconstruction data. This will allow us to examine how latent deconstruction potential relates to actual end-of-life performance. This concludes the research we would like to share with you today. Thank you very much for your attention.